Okay, so Alan, welcome back. So we continue with these exercises. This basically function needs to be, the derivative of this function needs to be calculated based on the first principle. So in the first principle we said that basically f prime, if you have f of x, then f prime of x is going to be equal to the limit of f of x plus h minus f of x over h when h tends to 0. So then what that means is that then if I calculate f of x plus h here, it will give me f of x plus h is equal to basically x plus h plus 1, and f of x plus h plus 1, x plus h plus 1, x plus h minus 1, and then you can put it in this formula to calculate your f prime of x. But as I may make a mistake, I'm going to calculate the derivative of the function using the quotient rule that we found, and then we come back here and calculate the derivative of the function. So the quotient rule was basically, we said that if you have some function like f of x divided by g of x, and if I wanted to take the derivative of this function d by dx of f of x by g of x, then what we did was that we said that we write this as d by dx of f of x times d by dx of times g of x minus f of x times d by dx of g of x over g of x whole squared. And so if I take for example my f of x, if I take it as u, and if I take it as v, I can write it as u divided by v whole prime, meaning the derivative of this function is going to be u prime v minus u v prime over v squared. And that is the quotient rule that we had, I suppose. I'm not wrong about that. U by v whole prime is equal to u prime v minus u v prime over v squared. So now I can use the quotient rule in order to calculate the derivative of this function, x plus 1 over x minus 1. X plus 1 over x minus 1. That means that here my u is x plus 1 and my v is basically x minus 1. So I can write x plus 1 divided by x minus 1 whole prime is equal to u prime, which is x plus 1 whole prime times v, which is x minus 1, minus u, which is x plus 1, times v prime, which is x minus 1 whole prime, over v squared, which is x minus 1 whole prime. which means that basically now the derivative of x plus 1, you know that d by dx of x plus 1 is equal to d by dx of x plus d by dx of 1. Now d by dx of x is equal to 1 and d by dx of 1 is equal to 0. So 1 plus 0 is equal to 1. And you know that d by dx of basically x minus 1 or v prime, x minus 1 or v prime is equal to basically d by dx of x, which is equal to 1 minus d by dx of 1, which is equal to 0. So this is also equal to 1. So then I can write this as x plus 1 whole prime, which is equal to 1 times x minus 1 minus x plus 1 times x minus 1 prime, which is equal to 1 over, and this is supposed to be squared. So x minus 1 squared is equal to, well, I just leave it as x minus 1 whole squared. So this is equal to basically x minus 1 minus x plus 1 over x minus 1 whole squared is equal to x minus 1 minus x minus 1 over x minus 1 whole squared, which is equal to x and negative x you can cancel out. You have negative 2 over x minus 1 whole squared. So negative 2 over x minus 1 squared. Negative 2 over x minus 1 squared. That is f prime of x. That is f prime of x. Now I can basically go back to the first principle and calculate the derivative of this function using the first principle. So then what I'm going to do is basically I need to calculate f prime of x, which is the limit of f of x plus h, which is basically this thing over here, x plus h plus 1 over x plus h minus 1 minus f of x, which is x plus 1 over x minus 1, and I need to divide this by h as h tends to 0. So I can write this as the limit of basically take the LCM here, x plus h minus 1 times x minus 1, and then if you divide you will get here you will get x minus 1 times x minus 1 times x plus h plus 1 minus, and if you divide here you will get x plus h minus 1 times x plus 1 divided by h as h tends to 0, and that is equal to the limit of, well, that is x squared. So the denominator is first x plus h minus 1 times well, I suppose we need to calculate that as well. So So that is x squared minus x plus hx minus h minus x plus 1, x squared minus x plus hx minus h, x squared minus x plus hx minus h minus x plus 1, and over here you have x squared plus hx plus x minus x minus h minus 1 minus x squared plus x plus hx plus h minus x minus 1 over h, as h tends to 0, and that is equal to, so x and basically x and negative x you can cancel out, and so here you have x squared plus hx minus h minus 1. Here you have, I can write this as negative x squared, and these two I can cancel out. So this is x squared, negative x squared, negative hx, negative h plus 1. So I can basically cancel all of this out, and then x squared and negative x squared I can cancel out, hx and negative hx I can cancel out, positive 1, negative 1 I can cancel out, and then over here I have a negative h, and over here I have a negative h over here, so the whole thing becomes negative 2h. Negative 2h. And over here I have x squared negative x plus hx minus h minus x plus 1. So I can write this as the limit of negative 2h over x squared minus 2x, x squared minus 2x plus hx minus h plus 1 over h, as h tends to 0, and so you know that if I had a denominator 1 over here, I could simplify. You see, if I had a plus b divided by c divided by d, I could write this as a divided by b times d divided by c, and then a and c could be simplified. A and c could be simplified because a is in the numerator here, c is in the numerator here, so a and c could be simplified. That means that this h and this h could be simplified. And now I have basically, now I get the limit of negative 2 over x squared minus 2x plus hx minus h plus 1, as h tends to 0, and when h tends to 0, then of course you can take this out, and that becomes just a negative 2, and then over here this goes to 0, and then you have x squared minus 2x plus 1, which is the same thing as negative 2 over x minus 1 whole squared, which is basically what we got. Over here. So that is that. So now the next question that we have is for the function f of x is equal to, I have a function over here, f of x is equal to x raised to the power 100 over 100 plus x raised to the power 99 over 99 plus all the way up to x squared over 2 plus x plus 1. Prove that f prime of 1 prove that f prime of 1 is equal to 100 times f prime of 0. 100 times f prime of 0. Basically this function is okay, so I had to do a couple of experiments before to solve this problem, and that is, the question is f of x is equal to x raised to the power 100 over 100 plus x raised to the power 99 over 99 plus all the way up to x squared over 2 plus x plus 1. And so basically we said that in the algebra of derivatives, we said that if we had basically f of x plus g of x, for example, two functions added together, we said that d by dx of these two functions added together would be equal to d by dx of f of x plus d by dx of g of x. So that is one thing, meaning that the derivative of this function is basically the derivative of each of the terms then added together. And basically this kind of, and then suppose that, for example, you want to take the derivative of x raised to the power 100 over 100. So we have basically some constant in the denominator. So I suppose you can use the quotient rule in order to find the derivative of this function. And the quotient rule was basically, if you have two functions, f of x and g of x, like something like this, d by dx of this function is going to be equal to basically, I don't want to give you the wrong information. It is d by dx of f of x times g of x minus f of x times d by dx of g of x over g of x whole squared. And we said that if we call, for example, f of x, for the sake of simplicity, call it u, and g of x, for the sake of simplicity, call it v, then u divided by v whole prime is equal to basically u prime times v minus u times v prime over v squared. So suppose you can use this, the quotient rule, and take this as just as a constant function, meaning that take u as, for example, x raised to power 100, and take v as, for example, 100, and write this as u prime would be basically 100 times x raised to the power 99, because d by dx of x raised to the power n is equal to n times x raised to the power n minus 1. So the derivative of u becomes basically this times g of x, which is equal to 100, and then you have minus f of x, which is x raised to the power 100, times d by dx of g of x, which is equal to 0. This is just a constant function, so you get the 0 over here, and then you have the derivative of I'm sorry, this function whole squared, which is basically 100 times 100. 100 times 100. And I suppose you get the hundreds, this, and you can cancel these two out and get x raised to the power 99. So that's basically one way of finding the derivative of this kind of function. As you can see, you get the derivative of, meaning that basically what you can say is that the derivative of the function becomes basically over here what I got was 100 times 100 times x raised to the power 99 over 100 times 100. Now if I cancel these two out, what I will get, what I can write this as 100 times x raised to the power 99 over 100. Now this part is basically the derivative of this function, meaning that d by dx of x raised to the power 100 is of course 100 times x raised to the power 99, which is this thing over here. And this part over here is basically the constant itself, which is 100, meaning that, for example, if you had a function like, for example, d by dx of x raised to the power 100 over, for example, 54, what you would get would be basically 100 times x raised to the power 99 over 54, something like this. And we can test this as well, meaning that you have, suppose that you have this function and you want to find the derivative of that based on this rule over here. So then u by v whole prime would be equal to u by v whole prime, assuming that u basically is x raised to the power 100 and v is 54, would be u prime, which is basically the derivative of this numerator, which is of course this is supposed to be, okay, over here we have 100 into x raised to the power 99 times v, which is 54, minus u, which is x raised to the power 100, times the derivative of v, which is 0, And then in the denominator I have 54 squared, which is 54 times 54. So again you can see that I have basically 100 x raised to the power 99 times 54 over 54 times 54, and these you will cancel out. So you can see that the derivative of x raised to the power 100 is 100 times x raised to the power 99, and then the 54 you can just write it over here as it is, and then that's the derivative of your function, of the whole function. Or if you had, for example, I don't know, for example, the d by dx of, for example, x raised to the power 3 over 4. We would write this as the derivative of x raised to the power 3 is equal to 3x squared over 4. And that would be the derivative of your function. Now coming back to this example over here. So now we know how to find the derivative of such functions where you have a constant in the numerator, right? So now what we need to do is basically d by dx of f of x, d by dx of f of x is equal to basically the derivative of this function, which is basically 100x. For example, this part over here would be 100x raised to the power 99 over the 100, and then these two would cancel out. You would get simply x raised to the power 99. So the derivative of this would be, the derivative of the whole f of x would be x raised to the power 99, and over here you would get x raised to the power 98, and the same thing would happen over and over again until you got, for example, to basically this would be just simply x, this would be 1, and the derivative of this would be basically 0, which you don't have to write really. So so that is basically the derivative of your function. Okay, now the question here is we want to prove something. We want to prove that f prime of 1 is equal to 100 times f prime of 0. Now f prime of 1 based on this, so f prime basically is f prime of 1 based on this would be 1 raised to the power 99 plus 1 raised to the power 98 plus all the way up to 1 plus 1. And this is basically 1 added together 100 times. So basically 1 raised to the power 99 is basically 1. 1 raised to the power 98 is equal to 1. And so on and so forth, plus 1 plus 1. So this was basically you go from basically 1 to 99, which is 100 times, 99 times. So this up to over here, this is 99 times. And then you have one term over here, so you have, in total, you have 100 terms. 100 terms. And if you add basically 1 to itself 100 times, you would get 100. You would get 100. Now, f of 0, f prime of 0 would be 0 raised to the power 99 plus 0 raised to the power 98 plus all the way up to 0 raised to the power 1 plus a 1, which is again 0 raised to the power 99 is equal to 1. 0 raised to any power is 1. Zero raised to the power, for example, 3 is equal to 0 raised to the power 99. Oh, I'm sorry, that's different. 0 raised to the power 99, for example, is 0. So this is a 0, and you will get just a 1 over here. All of these are zeros. Okay, so all of these are zeros, so you would get just a 1. That means that f prime of 0 is equal to 1. And f prime of 1 is equal to 100. F prime of 1 is equal to 100. So of course, if I write basically, so then based on this, f prime of 1 is equal to 100, and that is equal to 100 times f prime of 0, which is equal to 1, and 100 is equal to 100, which is true. That means that your RHS is equal to your LHS, and that's the end of the story. So the important thing here is to and one more thing that I wanted to show you here is why basically you get this sort of derivative related to these sorts of functions, meaning that we said that if your f of x is equal to x raised to the power, for example, 100 over 100, then f prime of x will be basically 100 times x raised to the power 99, which is the derivative of this function, over this constant, whatever that might be. Doesn't matter what that is. And that's basically the derivative of your function. Of course, you can cancel these two out. Now, let's do one of these derivatives by the first principle and see what happens. And basically, you need to see that in the process, what basically based on what happens in the limit, and basically why it just happens. So, for example, let's say you have f of x, which is equal to x cubed over, for example, 3. Now you want to calculate f prime of x. Now by the first principle, you know that f prime of x is equal to the limit of, or basically let's call it d by dx of f of x. d by dx of f of x, which is equal to f prime of x, is equal to the limit of f of x plus h minus f of x over h as h tends to 0. Now in the case of, for example, in the case of this function over here, f of x plus h, or this function, I'm sorry, in the case of this function over here, f of basically x plus h is equal to x plus h whole cube over 3. So you see that this 3 is not really important. If you make any changes to the variable, this 3 is not going to change because there is no variable here. Now, what's important here is now basically you need to put this in this relationship. So I can write basically f prime of x is equal to the limit of basically f of x plus h, which is this thing over here, x plus h whole cube over 3, minus f of x, which is x cube over 3, over h as h tends to 0. Now if you expand this, you will get the limit of x cube plus basically h cube. You know that a plus b whole cube is equal to a cube plus b cube plus 3a squared b plus 3ab squared. That's basically this thing over here. So x cube plus h cube plus 3x squared h plus 3x h squared, and then you have this minus x cube over here as well, and the whole thing you can divide by 3. The whole thing you can divide by 3, and then the whole thing divided by h, and you do that as h tends to 0. So you can write that as the limit of basically, and then x cube and minus x cube you can cancel out. You can write that as h cube plus 3x squared h plus 3x h squared, and then you can write this as 3 times h as h tends to 0. Now of course you can write that this way, because if you have, suppose you have a over b and divide that for example by some c, this is the same thing as a over b times 1 over c, which is equal to a over bc. Now if this is a, I have written this as a over b times c. B times c would be 3 times h, so I have written it this way. Now what you can do here is write this as the limit of, basically take an h out here, so you get h squared plus 3x squared plus 3xh over 3h as h tends to 0. So then if you cancel out h with h, then you can write this as the limit of basically h squared over 3 as h tends to 0 plus the limit of, for example, 3x squared over 3 as h tends to 0 plus the limit of 3xh as h tends to 0. Now when h tends to 0, this is going to be a 0 and this is going to be a 0. So then the limit of 3x squared by 3 as h tends to 0 is just going to be 3x squared over 3. So as you can see basically the function that I started with was x cubed over 3. So if you have f of x is equal to x cubed over 3, you see that, and the f prime of x that I got was basically 3x squared over 3. So that is basically the derivative of x cubed, 3x squared, and basically your 3 is basically, you can write it just as it is in the denominator, and that's the whole story. So that is basically that.